So the way we're going to do it is very simply, we go back to our two-period utility function. Although I'm going to have to extend that later to more than 2 periods, because certain aspects of the theory of health you can't really do in 2 periods. But we can start out and do a lot in 2 periods. So let's say the utility function I'm going to change my notation slightly. I'm going to call the probability of surviving, I'm going to have 2 periods. With some probability you survive through the 2nd period. You don't survive to the 3rd period. That's certain. I'm going to call the probability S. S is going to be probability of surviving. It's S for surviving. And S is going to be a function. It could depend like on S. I'm not going to deal with that here. That's your amount of schooling. We claim you could. And it's going to depend upon your expenditures on health. Afraid I'm going to use a similar notation. H, it's all defined here. H is expenditures on health. Okay. So you spend resources on health. It's going to be good. You could have time, but it's going to be good. Okay. And then you have utility here in the 2nd period. So it's a simpler version of the utility function we've been dealing with. Still only 2 periods though. Now, let me be a little bit explicit. I said this last time. Maybe you really want to write this. This is an expected utility. 1 minus S times the utility if you die. That would be a fuller utility function, right? Now, utility if you die, there may be some big utility. You go to heaven or whatever. And if we look at what we have here, we would have S times U, let's say, alive, living, minus UD, plus UD. Okay. So really what we're looking at is the difference between the utility of living and dying. Okay. Now, if the utility of dying is independent of all the decisions we're making, like H and survival, we can just treat that as a constant and then get rid of it, normalize that, right, to 0. Even though it could be very important, it's a constant. You just have to recognize you're looking at the utility, the difference between the utility of living and dying. Okay? And by being a constant, it means, well, when we differentiate everything, we don't. It's just going to be a constant. And here, if it's a constant, we're really just differentiating this or this, and then looking at this difference. And I'm just going to normalize it to 0 so that this is the utility of living. I'm not going to keep writing utility of living, right? And this is 0, so this is 0, and that's fine. So as long as it's not endogenous, you can do that. Okay? And I should add here a discount rate, beta. I shouldn't. It could